Hello everyone, this is another video and this is on electromagnetism. There will be some numericals in it. So, electromagnetic field. The first question: there is a potential given Vxy that is equal to 4 e to the power 2x plus fx minus 3y square. Okay, so given that the x component of an electric field, x component of electric field Ex and V at 0 at origin. So find fx. Vxy is equal to 4 e to the power 2x fx minus 3y square. Find fx. It's given what is given? Ax is equal to 0 at 0 0 and v is equal to 0. So what is Ex? We know Ex is minus del v by del x. Minus del v by del x. So minus del by del x of minus del by del x of 4 e to the power 2x plus fx minus 3y square. So that implies 8 e to the power 2x plus x. Okay. So this is your e to the power x, ex, which is in fact 0 at origin. So if I write e to the ex and minus 8 e to the power 2x plus x is equal to 0 when origin, that means x is equal to 0. So minus 8 plus 0 is equal to 0. And the 0 is equal to 8. Okay, if the 0 is equal to 8, so now potential is how much again? 4 e to the power 2x. Uh, okay, there is a mistake here. This one should be minus 1, so minus 8. It's 4 e to the power 2x plus fx minus 3y square. Right. So v at origin are also 0. So 4 let's say f of 0 minus 0 is equal to 0. So f of 0 is minus 4. Okay. So 0 is minus 4. And now mm, have to find fx, isn't it? Okay, we know from Poisson's equation. Poisson's equation del square V is equal to rho by epsilon naught. Okay. Mm, so here it is thing 0. So if we minus del square by del x square, um, plus del square by del y square, V is 16 over 2x plus f double dash x, okay, minus 3, minus 6, okay, minus 6. So this is your what? This is your del square v by del x square, 16 over 2x plus f double dash x, del square v by del y square is a minus 6. Okay, this is equal to actually 0. This is equal to 0. So if we equate this, 16 over 2x plus f double dash x minus 6 is equal to 0. So f double dash x we are getting from this 6 minus 16 over 2x. Okay, so f dash x is 6x minus 8 e to the power 2x plus c1. Fx is equal to 3x square minus 4 e to the power 2x plus c1x plus c2. And now we had f dash 0 is equal to minus 8, f0 is equal to minus 4, f dash 0 minus 8, f0 is equal to minus 4. So let's put it here. So 0 is equal to minus 4 plus c2, that is minus 4, c2 is equal to 0. F dash 0, so minus 8 is equal to minus 8 plus c1, c1 is also 0. Yeah, c1 is 0, c2 is 0. So what is fx then? Fx is equal to, just put c1 0, c2 0, so fx will be 3x square minus 4 e to the power 2x. Did you get it? This will be the answer. Okay. Yeah. First of all, we did ex is del v by del x minus del v by del x. From that we got f dash 0, then f0. Then we just did some like normal algebra only, like calculus, and we got just c1 0, c2 0, and we put it here, and we got this. Okay. Question number 2. Question number 2. In the electrostatic potential, okay, electrostatic potential, the electrostatic potential in spherical polar coordinate means is phi r is equal to phi naught e to the minus r by r naught. Then the charge density, then the charge density at a distance, at a distance r is equal to r naught will be how much? Option A, epsilon naught phi naught by e r naught square. Option B, e epsilon naught phi naught by 2 r naught square. Option C, minus epsilon naught phi naught by e r naught square. Option D, minus 2e epsilon naught phi naught by r naught square. Right. So let's do this one. What is given here? Potential, electrostatic potential is given. So the charge density at a distance r is equal to r naught. So electrostatic potential phi r is equal to phi naught e to the power minus r by r naught. We know Poisson's equation del square phi or del square v is equal to the phi here rho by epsilon naught. Okay. Del square phi is equal to rho by epsilon naught. Isn't that right? Hmm? So how to solve this? Minus sorry. I get to minus 12 minus rho by epsilon naught. Mhm. So the rho is actually our charge density. So rho is minus epsilon naught del square phi. Rho is minus epsilon naught del square phi, where phi is how much? Phi naught e to the power phi is rho is equal to phi is e to the power phi naught e to the power ah, minus r by r naught minus r by r naught. Okay. So how to deal with this? So del square phi will calculate. Del square is what? What is del square? 1 by r square. Del by del r of r square. Del by del r of phi. You know this or not? Yeah. Del phi. This is the actual one. Okay. Don't be confused here. 1 by r square del by del r of r square del phi by del r. 1 by r square del by del r square del by del r of my sorry del by del r of phi naught e to the power minus r by r naught 1 by r square del by del r of r square. First of all, phi naught, take the phi naught out, and this is minus 1 by r naught to the minus r by r naught, and yeah. So this will be r naught. Take the r naught out now. R naught out. Phi naught r square r naught phi minus out del by del r of r square e to the power minus r by r naught. Okay. So I'll write it again. Minus phi naught r square r naught del by del r of r square e to the power minus r by r naught. So minus phi naught by r square r naught. Sorry. 2r e to the power minus r by r naught. Minus r square by r naught e to the power minus r by r naught. So minus phi naught r square r naught e to the power minus r by r naught. 2r minus r square by r naught. We are asked what is in the question. We have to find r at r is equal to r naught. So everywhere put r is equal to r naught. So minus r phi by r naught cube e to the power minus r naught by r naught. 2r naught minus R naught square by R naught. This is cancelled out. So what is it? What is it I'm getting? Minus 5 by R naught Q e to the power minus 1, and this one is R naught. So I'm getting minus 5 R naught square e. Okay, and there was, if you remember, this is only this one. What is the rho? Rho is actually what? Minus epsilon naught del square phi. So minus epsilon naught into minus phi naught R naught square e. So phi naught epsilon naught R naught square e. That is a rho. Is that okay with you? Is that alright with you? Yeah. Yeah. Next. Next write down. Next is multiple expansion. Next is given heading multipole multipole expansion. Okay, multipole expansion. So potential, we know potential is if there is a dipole. Potential of a dipole is 1 by 4 pi epsilon naught p cos theta by r square. This is the potential due to the dipole. Potential due to dipole. Okay. So E electric field is 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught p by r cube. Okay. 2 cos theta r cap plus sin theta r cap. These are all right. Potential energy, we know potential energy U is equal to minus P dot E. Okay. Yeah. All right. Okay. Now monopole moment. What is monopole moment? Monopole moment is equal to summation n is n to 1 n q, and that is a monopole moment. What is dipole moment? Dipole moment is what is dipole moment? Dipole moment is summation n is equal to 1 to n q and r n. Is that all right? Okay. Now we'll do it table. This is a pole potential, and this is your electric field. This is your electric field. So this is your monopole. This is a dipole, and this is a quadrupole and octupole. So monopole potential is inversely proportional to R. This is, it will just keep on increasing like this. Okay, and electric field is proportional to 1 by R because electric field is the divergence of like no gradient of potential. So the power will just increase 1 and negative. Is that all right? So you need to remember this. Just remember monopole potential is this. Everything will automatically set into your mind. Is that clear? Is that clear? Yeah. Yeah. Okay. Next, then question number three. Question number three. Uh, four charges are four charges are kept fixed. Are kept fixed uh, like 2 plus q charges into minus q charges at fixed at the four vertices of at the four vertices of a square of side A, square of side A as shown in the figure. Okay. As what is the figure? 4 charges plus q minus q plus q minus q p. Okay. This is R. This is A. All right. At the point at the point P, which is at the point which is at a distance at the point which is at a distance r greater than a r very very greater than a, the potential is proportional to okay, and the potential is proportional to what? Option A 1 by r, 1 by r square, 1 by r cube, and 1 by r cube options. So if you see, four charges are kept fixed at the four vertices of a square at the point P. What is the potential? So this is what you can see: four charges, q minus q plus q minus q. So this is a what? This is a quadrupole, isn't it? So for quadrupole, what is the potential dependence on like what is the r potential is dependent on r. For monopole, it is what proportional to one by r. For dia, it's one by r square. What is then quadrupole? One by r cube. So this is proportional to one by. Simple question. All right, but it's only simple if you have remembered the table, right? It's just that we have just done the table. That's why it feels simple. But in the exam, uh, you'll be wondering what is it? What is the proportionality? Okay. Yeah. Okay, let's do another one similar type where another a bit more concept will be used here. The next question number 4. Okay, so this is a diagram. So there is a minus q here at the center, minus q by 2. Then there is q here, minus q by 2, q here. Okay, and this is a distance a. So this is a square again. A, A, A. Okay, so the question is, um, V is the electrostatic potential at a point P at a distance from R very very greater than A. Okay, let P be a point at a distance R very very greater than A from the center of the square, from the center of the square. Okay, then the value of V of 2R divided by V of R is how much? Now, I'll try to solve it. Okay, now try to solve it. See how to solve this kind of question. First, we have to calculate charge, monopole charge. Okay, simple as summation of charges minus q by 2 plus q minus q by 2. Is that all right? And there is also minus q by at the center. So if you see, this is 0. Okay, this is minus q minus for minus q. This is 0. So monopole moment is 0. That means next we have to check is dipole moment. How will we check dipole? Summation qi ri. Okay, summation qi ri. Is that right? If you see summation qi ri, how will you check it? How will you check it? Hmm. You have to pick an origin here. I have to pick an origin. For example, this is the origin. Take the reference point. So if this is the origin, this point is a. Sorry, this point is zero a. This is your a zero. This is your what? Root two a. Root two a and a. Is that right? I'm sorry. This is a. Yeah, a. This is zero a. This point is how much? This should be a by 2, isn't it? A by 2. Is that right? So you have to choose a point. This is the origin. So according to that, we will do it. So q into 0 I cap plus 0 j cap. This point. Minus q by 2 a I cap plus 0 j cap. Is that all right? Plus q, I'm going here. A I cap plus a j cap. Okay. Minus q by 2 0 I cap plus aj cap. Is that all right? And there is another point I like here minus q a by 2 I cap minus plus a by 2 j cap. Okay, this becomes 0. Hmm. Now if you check, mm, you have to check the other ones. Okay, you have to check the other ones. See if you check, this is minus q by 2a minus q by 2a. That will give me minus qa. That's minus qa will add up with. Yes, minus q by 2 will add up with what? That will add up with qa. That will give me 0. Again, this is 0. This is here minus q by 2a. Minus q by 2a. This is minus q by 2a will give me minus qa. And this will add up with this will give me 0. So everything adding up will give me 0. So q dipole is equal to 0. So if q dipole is also 0, that means dipole is also absent. So what we are looking for now then? Q quadrupole. Is that all right? Is that all right? Q quadrupole. Okay. So Q quadruple will be there. So Q quadruple. Okay. So Q quadruple for Q quadruple we know what potential is proportional to 1 by RQ, right? So V2R by VR, that will be 1 by 8 RQ divided by 1 by RQ. That will be 1 by 8. That will be. Is that all right? That's the answer. 1 by 8 is the answer. Okay. Yeah. 1 by 8 is the answer. Okay. Is that all right? Okay. Next write down. Next write down method of images. Method of images. Okay, method of images here. What is the, how is the how will you recognize this question? The question will have words like grounded, infinite, conducting plane sheet, conducting plane sheet, and point charge, and point charge. All right. So here number of images is what? Number of images. Number of images n is equal to 360 by theta minus 1. Okay. Yeah. Okay. And the question number 5, I think. Question number 5. A point charge Q, a point charge Q of mass m is kept, write the questions, at a distance d below, at a distance d below the ground, below a grounded infinite conducting sheet which lies which lies in the xy plane, which lies in the xy plane. What is the value of d? What is the value of d for which the charge remains stationary? Charge remains stationary. Okay, what is the value of d for which the charge remains stationary? Point charge q. So the options are q by 4 root over of mg pi epsilon naught, q by root over of mg pi epsilon naught, z infinite mg pi epsilon naught by q. So a point charge q of mass m is kept at a distance d below a grounded infinite conducting sheet which lies in the xy plane. What is the value of d for which the charge remains stationary? Point charge q is kept at a distance d below it. For example, this is a grounded conducting infinite plane sheet. There is a charge here. Okay, in the xy plane. What is the value of d? Okay, this is d for which the charge remains stationary. Okay, if there is a charge d here, there will be another mirror charge here, and opposite with opposite charge. Okay, same but opposite charge here at the same distance. So if you can calculate these two values, okay, like force between them, but it will remain stationary. How will it remain stationary? If the gravitation force is equal to the electrostatic force between them, isn't it? Is that all right? Yeah. So we'll do it. Very easy question. Nothing else is there. Again, I will draw this. So this charge is here at a distance d, and exact mirror charge will be here at a distance d, but opposite sign. Okay. So the force between them, force electrostatic force is 1 by 4 pi epsilon naught q square by 2d whole square. That means 1 by 4 pi epsilon naught. Okay, q square by 4d square. Is that all right? So this force should be for it to be stationary. For it to be stationary, Fe should be equal to F, gravitational force. Gravitational force is mg. Mg is equal to then 1 by 4 pi epsilon naught q square by 4d square. All right. So what is the distance that is asked? So d square I will take to this side, 1 by 4 pi epsilon naught q square by 4 mg. Okay. So what would be d? D would be q by root over of 16 pi epsilon naught mg. 16 if you take out, that will be what? D is equal to q by 4 root over of pi epsilon naught mg. Isn't that right? So that should be your answer. Okay, what is it? Option A. Okay, option A should be the answer. You got it? Yeah, that's the answer. Okay, so that is your number 5 question. Okay, let's go to number 6. Question number 6. Question number 6. A point charge Q is placed symmetrically at a distance d at a distance d from two perpendicularly placed grounded grounded conducting infinite plates grounded conducting infinite plates as shown in the figure. The the net force on the charge is point is q is placed symmetrically at a distance d from two perpendicularly placed grounded in conducting infinite plates. Point is q is placed perpendicularly, okay, like this. Q is this at a distance d distance perpendicularly from a placed grounded conducting infinite plates. These are the two infinite plates. The net force on the charge q. First of all, there are two conducting plates. Two conducting plates. So how many images will be there? We know what number of images will be. How many images will be there? 360 by n by 360 minus theta minus 1. So 360 by 9 minus 1, that will be 3 images will be there. One will be here, here and here. If I draw this, see, the q is here, right? This is d, this is d. So another, this will be minus, yeah, minus q will be there. Uh, this distance is d. Now this is d, q will be here, another q will be here. This is d, this is minus q will be here. So three images, okay, three images. What is the question? What is the question? Yeah, the net force on the charge is, okay, let's calculate. Nothing else is there. Net force on the charge. So if we can calculate all the distances, we can have the force. So this is 2d distance. This is 2d distance. This distance is how much? This is like a square with all the sides are 2d. So this should be what? Root 2 into a, that is root 2 into 2d, that is 2 root 2d. Alright? Okay. So but we have to do it very carefully because the okay, wait. So um okay, yeah, f resultant would be how much? 1 by 4 pi epsilon, I will take it out, and okay, q square will also be there. So we'll just do the coordinates here. For this one, the coordinates are what? It's 2d, right? Where is the distance here? 2d minus 2d. I'm sorry. 1 by, yeah, 2d whole square minus I cap. The force between them will be in which direction? In this direction towards negative. So minus I cap plus for this now 1 by 2 root d whole square. Force direction will be outwards like this. That will be I cap plus j cap. For this one plus 1 by 2d square, the force distance, force direction will be downwards, isn't it right? So minus j cap. Okay. So q square by 4 pi epsilon naught d square 1 by 4 minus I cap 1 by 8 I cap plus 1 by 8 j cap minus 1 by 4 j cap. Okay. So this is kind of this. This is what is it. So if I do this simplification, so q square by 4 pi epsilon naught d square. Uh, okay. 1 by minus 1 by 4 I cap plus 1 by 8 I cap plus 1 by 8 j cap minus 1 by 4 j cap. That's what it is. So q square by 4 pi epsilon naught d square. This is your 8 minus 2 plus 1 I cap plus 8 2 sorry 1 minus 2 j cap. So q square by 4 pi epsilon naught d square minus I cap minus j cap whole divided by 8. Okay, so the answer is what? Q square by 32 pi epsilon naught d square minus I cap plus j. Okay, so that's the answer. Isn't that the answer? Yeah. Okay. Okay. Next question. Question number 7. Question number 7. 2 point charges plus 3q and minus q are placed at 00d and 002d respectively. Okay. Above an infinite grounded conducting plane sheet kept in xy plane at a point 00z where z very very greater than b, the electrostatic potential electrostatic potential of this charge configuration would approximately be, okay, 2 point charges plus 3q and minus q are placed at respectively of infinite grounded conducting plane sheet kept in xy plane at a point 0, 0 z. The electrostatic potential of this charge configuration is approximately, okay. So let's draw the diagram first. Draw the diagram first. So this is the minus q is at 0, 0, 2d. 3q is 0, 0, d. At a point 0, 0, z, the electrostatic potential of this charge distribution. This is z axis, of course, because z coordinates are given. This is grounded. So this is d distance. That means at exactly d distance there will be another minus 3q. This is 2d distance. That means exactly at a 2d distance there will be plus q. Isn't that right? So at a point here 0, 0, z, you have to find what electrostatic potential. Okay. So now see for potential we know what is it? Okay. Potential we know for calculating the potential dependence of distance. We have to find first q monopole. If it is zero, then we have to find q dipole. If it's zero, q quadrupole, like that. Okay. So let's try. See here, q monopole will be how much? Q mono. The summation of charges, that is minus q plus 3q plus q minus 3q, that is 0. So this is absent. Q dipole. Okay, for it we have to take a reference point, that is 0, 0. For example, 0, 0, 0. So from here I will take everything, all the distance. So 3q into d minus q into 2d minus 3q into d plus q into 2d. Okay, but here everything should be like it is z cap. This is minus z cap, isn't it? Minus z cap. This is minus z cap, or what? Yeah, that's right. Yeah, that's right. So that will be 3qd z cap minus 2qd z cap plus 3qd z cap minus 2qd z cap. Is that all right? Yeah. So here if you see, this is 6 minus 4. So 2qd z cap. So q dipole is not equal to 0. So q dipole exists. Q dipole exists, right? So for q dipole we know, for dipole we know what v is proportional to 1 by r square. Isn't that right? Okay, and electric field is proportional to 1 by r. What is asked here? Potential is asked. So v is proportional to 1 by r square. R is what here? Z. So v is proportional to 1 by z square. Alright. So actually this question had some options. I hadn't given option. And in the options, if the option which had v proportional to 1 by z square, that will be the correct answer. Is that alright? So whenever you are asked a potential due to a charge configuration, okay, potential due to a due to any charge configuration, what you have to do first, check the monopole moment. Okay, dipole moment. Okay, if monopole is zero, then go to dipole. If dipole is zero, go to quadrupole. If quadrupole is zero, go to next. So where it stops, for example, dipole is not zero, so then dipole exists, and according to that, you will give the proportionality. Okay, that is the way to solve this kind of question. Is that all right? Okay, yeah. Okay, so yeah, this should be it for this class. Okay, we solved how many questions? Otherwise, you write one more. This was what number? 7. So number 8. I had a question. A charge plus Q is kept at a distance of is kept at a distance 2r from the center of grounded conducting sphere. Okay, find image charge and its distance from center. Okay. A charge q is placed at a distance of 2r from the center of grounded conducting sphere. Find the image charge and distance from the center. Alright. Okay. In these questions, there are two formulas. You just have to remember these two formulas. Okay. Q will be, from write down the formula, minus r by a q, and distance your um, magnitude of, okay, distance b will be r square by a. So if we apply this formula, so q dash will be what, minus r by, what is the distance here, 2r into q, that is minus q by 2, simple. And b will be what, r square by 2r, that is r by 2. See how simple it is, but you just have to remember the formula you have to remember, otherwise it's not easy. Okay. Okay, yeah, that'll be it for this class, and we'll solve more questions in the upcoming sessions. Thank you.